In parts of the Illinois River, a fish that once seemed unstoppable is finally losing ground. For nearly 2 decades, every survey showed the same thing: more carp every single year, no exceptions. Then the trend line bent the other way, and the real explanation behind that shift is more interesting and a lot more grounded than most of the viral versions of this story you might have seen floating around online. Let's start with how bad things actually got, because the scale of this invasion is hard to overstate. Silver carp and bighead carp, both native to major river systems in China and eastern Russia, were brought into the United States in the 1960s and 70s for a genuinely practical reason. Fish farmers and wastewater treatment operators wanted a species that could filter out excess algae and plankton from ponds and lagoons, cutting down on pollution without using more chemicals. It worked, in the sense that the fish were extremely good at that job. The problem showed up when flooding and accidental releases during the following decades let those fish escape into the Mississippi River system. From there, they spread fast, working their way up through connected waterways, including the Illinois River, which links the Mississippi all the way up toward Lake Michigan and the rest of the Great Lakes. Once they were loose, the carp thrived in a way almost nobody predicted. Silver carp and bighead carp are filter feeders, meaning they eat by straining plankton directly out of the water column, and American rivers turned out to have exactly the kind of food supply they needed in huge abundance. They grow fast, they reproduce in large numbers, and for a long time they had essentially no natural predators in these rivers big enough or common enough to put a dent in their population. By the 2000s, surveys in some stretches of the Illinois River were finding that Asian carp made up somewhere around 60 to 70% of the total fish biomass, meaning if you added up the weight of every fish species combined in some reaches, most of it was carp. Anyone who has seen video of silver carp launching themselves out of the water by the dozens when a boat motor disturbs them knows exactly how dense these populations became. For years, the fight against this invasion looked mostly hopeless. Electric barriers were built on the Chicago Sanitary and Ship Canal specifically to stop carp from reaching Lake Michigan, and they've done real work slowing that specific migration route, but they were never designed to eliminate the carp already established downstream. Commercial harvest programs started up, paying fishers to net and remove carp in bulk. Researchers ran surveys year after year, and for a long stretch, the population numbers kept climbing anyway, because removing adult fish doesn't do much if new fish are being born and surviving faster than the old ones are pulled out. But starting in the 2010s, something genuinely did start to shift, and the real driver behind it is worth understanding clearly, because it's not some hidden mystery. It's the direct result of one of the largest sustained fish removal operations in American history. Beginning around 2010 in the upper river sections closest to the Great Lakes, and expanding after 2019 to cover the lower Illinois River as well, state and federal agencies dramatically scaled up commercial harvest contracts. These aren't small operations. Commercial crews working under contract with state fisheries biologists have been pulling carp out of the Illinois River by the millions of pounds every single year. In 2024 alone, crews removed more than 7 million pounds of invasive carp from the Illinois River system. Since these programs began, the cumulative total removed from the river now sits somewhere north of 45 million pounds, and that number keeps climbing every season. The Illinois Department of Natural Resources has pointed to specific stretches near the Brandon Road area, the critical choke point closest to Lake Michigan, where sustained removal effort is estimated to have cut the local carp population by roughly 2/3 compared to where it once stood. That's the headline fact that tends to get skipped over in more sensationalized retellings of this story. This wasn't an accident nobody planned. It's the direct, intended result of a large, well-funded, carefully targeted harvest campaign run by people whose entire job is figuring out how to remove enough carp fast enough to actually bend the population curve. Researchers monitoring zooplankton, the tiny organisms that carp feed on and that form the base of the food web, have been tracking whether reduced carp numbers actually translate into a healthier system underneath them. And the removal effort is treated as a genuine management success story precisely because it's been measured, tracked, and repeated season after season with real data behind it, not stumbled into by chance. Now, here's where the story gets more interesting, and where a real additional piece of the puzzle comes in: alligator gar. Alligator gar are enormous, primitive-looking fish native to the Mississippi River Basin and other big river systems across the American South and Midwest. Adults can grow past 6 feet and beyond 100 pounds, with some documented individuals far larger than that. They're an ancient lineage with a fossil record that stretches back tens of millions of years. And unlike Asian carp, they belong in these rivers. They evolved there. For most of the 20th century, though, alligator gar were treated as a nuisance. Wildlife agencies and states across their range ran deliberate campaigns to reduce or eliminate them, assuming, incorrectly, that they competed too heavily with more popular sport fish. By the middle of the century, alligator gar had vanished from large parts of their historic range, including much of Illinois, where they hadn't been documented in modern surveys for decades. Starting in the 2010s, states including Illinois and Missouri began reversing course, launching hatchery-based reintroduction programs specifically aimed at restoring alligator gar to rivers where they used to live. The Illinois Department of Natural Resources began releasing hatchery-raised juvenile gar into the Illinois River system and connected waterways like the Kaskaskia River starting around 2010, with similar efforts following in the Kaskaskia specifically from 2012 onward. These programs were framed around biodiversity and restoring a native species that belonged there, correcting a mistake made by earlier generations of wildlife management. Given how the carp invasion had exploded in the meantime, researchers and fisheries managers were understandably curious whether bringing back a genuine native apex predator might also help take a bite, literally, out of the invasive carp population sharing the same water. Here's where it's important to be honest about what the actual research shows instead of overselling it. Alligator gar are opportunistic predators. Studies of their diet have consistently found that their preferred prey tends to be species like gizzard shad, along with other rough fish. And they will absolutely eat smaller Asian carp when the opportunity presents itself, particularly during the first few months of a young carp's life, before it grows too large for a gar to physically swallow. And once carp pass that early juvenile window, their body size quickly outgrows what most gar, even large ones, can realistically take down. Fisheries biologists who specialize in alligator gar, including researchers who've spent years pushing for their reintroduction, have been careful and consistent on this exact point in public statements. Gar are not a solution to the Asian carp problem by themselves. As Randy Sauer, a fisheries biologist with the Illinois Department of Natural Resources who has overseen gar stocking efforts, put it, the realistic goal has been something like 1 or 2 gar per river mile in early restoration stages, compared to carp numbers that are still measured in tons per mile in the most heavily invaded stretches. That's not a typo. It's an enormous mismatch in scale, and it's exactly why researchers in this field, including specialists like Alisi Ferrara at Nichols State University, who has studied alligator gar extensively, have pointed out that nobody has found a way for gar alone to meaningfully control an established carp population at the scale these rivers are dealing with. So why bring gar back at all if they can't solve the carp problem on their own? Because the goal was never carp control in the first place. It was ecological restoration, correcting a mistake and putting a genuinely important native predator back into a food web it had been artificially erased from for half a century. Any benefit towards slowing carp recruitment in the earliest life stages is a welcome side effect, not the main event. And the scientists running these programs have generally been upfront about that distinction rather than letting the story get inflated into something bigger than the evidence supports. There's also a separate, genuinely interesting line of research worth mentioning here because it points toward native predators playing a real role in this story, just not in the dramatic, single-hero way some retellings suggest. Researchers at the Illinois Natural History Survey, including fisheries biologist James Lamer, published findings in 2023 examining whether largemouth bass, a much more common native predator already present throughout these river systems, prey on young Asian carp in a size-selective way. Their research found real evidence that bass do target juvenile carp within a specific size window, adding another native predator into the picture that had been mostly overlooked in earlier assumptions about the invasion being essentially unstoppable by anything already living in these rivers. It's a smaller, less headline-grabbing finding than a dramatic gar versus carp showdown, but it's backed by actual published, peer-reviewed data, and it fits into a broader pattern researchers are increasingly interested in. Native predators, working alongside sustained human harvest effort, contributing incrementally to slowing recruitment rather than any single species flipping the whole system on its own. Put these two threads together, the massive deliberate harvest campaign and the slower, more limited contribution from restored and existing native predators, and you get a genuinely accurate picture of why carp numbers have started softening in specific stretches of the Illinois River. It isn't a mystery nobody planned. It isn't a secret predator quietly winning a war nobody noticed. It's the product of a well-funded, well-documented removal campaign that has pulled tens of millions of pounds of carp out of these rivers over the past decade, combined with an emerging, honestly modest contribution from native fish, including newly reintroduced alligator gar and existing largemouth bass, chipping away at survival rates during the vulnerable early stages of a carp's life. That doesn't mean the fight is over, and it's worth being clear about that too, because overstating a win can be just as misleading as inventing a secret cause. Even with tens of millions of pounds removed, Asian carp remain firmly established across huge stretches of the Mississippi River Basin. And researchers, including scientists at agencies like the U.S. Geological Survey, continue actively developing new tools, acoustic deterrence, targeted attractants, improved monitoring using environmental DNA sampling from river water to track population trends without needing to physically net every fish. Environmental DNA work, which detects genetic material that fish naturally shed into the water through waste, mucus, and scales, has become an increasingly important tool for tracking whether carp populations are actually declining in a given stretch of river, or whether fish have simply moved somewhere else. That kind of monitoring is exactly what lets agencies confirm whether a harvest program near the Great Lakes is actually working, rather than just hoping it is. The bigger picture worth taking away from all this is actually more encouraging than a story about an accidental miracle predator, not less. It shows that a coordinated, well-funded, patiently sustained management effort, backed by real monitoring and real data, can measurably bend the trajectory of one of the worst freshwater invasions in American history. That's not a small thing. Invasive species problems, this large, usually don't have tidy solutions, and total eradication of Asian carp from the Mississippi Basin at this point isn't considered realistic by the scientists working on it. But meaningfully reducing density in the corridors that matter most, especially the stretches closest to the Great Lakes, where the ecological and economic stakes of an actual carp establishment would be enormous, is a genuinely achievable, and in specific stretches, an already partly achieved goal. The alligator gar side of the story deserves its own spotlight too, separate from the carp fight, because restoring a native species that people spent decades deliberately wiping out is worth paying attention to on its own terms. These fish survived mass extinction events that wiped out the dinosaurs. They can live past 50 years, with some documented individuals living considerably longer, verified through bone and scale aging techniques that read growth rings much like counting rings in a tree trunk. Watching a species like that slowly reestablish itself in rivers where it hadn't been seen in half a century, thanks to hatchery programs, careful stocking, and patient multi-year monitoring, is a genuine conservation success story regardless of what it does or doesn't do to the carp population living alongside it. There's also a slower, quieter, ecological story unfolding underneath all of this that researchers are still piecing together. Heavy carp populations disturb river sediment and consume massive amounts of plankton, which increases water cloudiness and blocks the sunlight that submerged aquatic plants need to grow. Those plant beds matter enormously because they provide habitat for native invertebrates and shelter for young native fish. In stretches of the Illinois River, where carp density has meaningfully dropped thanks to sustained harvest, researchers with long-term monitoring programs run jointly by the Army Corps of Engineers and the U.S. Geological Survey have recorded early signs of improving water clarity and modest recovery in submerged vegetation in specific backwater areas. Whether that translates into a broader rebound for native fish populations over the coming years is still being actively studied, and scientists are appropriately cautious about calling it a full recovery this early. But it's a real, measurable, and genuinely hopeful signal, and it's directly connected to the reduction in carp biomass that harvest programs have achieved. So the actual headline here isn't that a mystery predator nobody planned for saved the day. It's that a massive, deliberate, well-documented removal campaign run by people who knew exactly what they were trying to do has started to work in specific corridors, and it's being reinforced in a real but modest way by the slow return of native predators like alligator gar and the predation habits of species like largemouth bass that were already living there the whole time. That's a less dramatic story than a hidden hero nobody saw coming, but it's the one actually backed by the data, the harvest numbers, and the researchers who've spent their careers working on this exact problem. It's also worth remembering how young this fight still is in ecological terms. Alligator gar take roughly a decade to grow large enough to matter as predators, and even longer, more than a decade for males, and closer to 11 years for females, before they're capable of reproducing on their own in the wild. Fish stock today won't meaningfully contribute to the food web until well into the 2030s. That means whatever role native predators end up playing in this story is still mostly ahead of us, not behind us. The harvest campaigns, meanwhile, have to keep running indefinitely because carp reproduce fast enough that stopping the removal effort, even for a few seasons, would likely let the population rebound. It's worth pausing on just how much money and coordination sits behind this effort, because that scale is part of why it's actually working instead of just being another well-meaning program that fizzles out. The Invasive Carp Regional Coordinating Committee, made up of more than 24 federal, state, and Canadian agencies, coordinates the harvest strategy across the entire Illinois River system, splitting the work into zones based on where carp density and reproduction risk are highest. The upper river section, closest to the Brandon Road area and the electric barrier system protecting Lake Michigan, gets the most intensive, most tightly targeted removal effort, because that's the corridor where even a small number of carp slipping through could eventually mean an establishment event in the Great Lakes themselves, something officials across the region have spent years trying to prevent. The lower river, where carp densities are far higher and all life stages are present, gets a larger scale harvest operation, boosted by state incentive programs that pay commercial fishers more per pound to keep removal rates high enough to actually outpace reproduction. Beyond the barrier system and the harvest boats, there's also the Brandon Road project itself, a proposed set of additional deterrents, including engineered water jets, underwater speakers producing sound deterrents, and a bubble curtain designed to disorient and discourage fish from passing through a key lock and dam structure. It's a genuinely expensive undertaking, with a projected federal cost in the hundreds of millions of dollars, and it's been moving through planning, funding, and construction phases for years, which says something honest about how slow and difficult large-scale infrastructure projects like this are, even when everyone involved agrees on the goal. None of this is secret or accidental. It's a long, visible, sometimes frustratingly slow public process, tracked in annual reports, congressional funding requests, and public agency updates, which is a very different picture from a stalking program quietly running a suppression operation nobody noticed for 15 years. The economic stakes behind all of this effort are also worth understanding, because they explain why so much money and coordination has gone into a fight against a single group of fish species. The Great Lakes support a commercial and recreational fishing industry worth billions of dollars, along with tourism, boating, and property value tied to lake water quality. Silver carp and bighead carp, if they ever established a breeding population inside the Great Lakes themselves, could realistically disrupt that entire food web, since these carp compete directly with native and sport fish species for the same plankton-based food supply that supports everything higher up the chain, including the species that Great Lakes fisheries depend on economically. Ecologists studying the broader risk, including researchers connected to NOAA's Great Lakes Environmental Research Lab, have pointed out that the danger isn't just carp displacing a few species here and there. It's the possibility of an entire food web getting reorganized around a filter-feeding invader that consumes the base of that web faster and more efficiently than almost anything already living there. That's the scenario the barrier systems, the harvest boats, and the Brandon Road Project are all specifically trying to prevent. It's a big part of why the funding and political attention behind this fight has stayed as strong as it has for over a decade now. The environmental DNA monitoring mentioned earlier deserves a bit more explanation too, because it's genuinely one of the more clever tools researchers have developed for tracking a problem this large. Instead of relying only on netting and electrofishing surveys, which can miss fish or misrepresent true population density, depending on where and how the sampling happens, scientists now regularly collect water samples from fixed points along the river and test them for traced genetic material shed by fish simply living and moving through that stretch of water. A rising or falling concentration of carp DNA in a given stretch gives researchers an independent molecular level check on whether the removal effort is actually reducing the number of fish present, rather than just making them warier or pushing them into different sections of river. This kind of monitoring has become a standard part of how agencies track progress now, alongside the physical harvest totals and traditional survey data, giving researchers multiple independent lines of evidence that all need to agree before anyone declares real progress. The largemouth-based research from the Illinois Natural History Survey is worth returning to as well, because it's a good example of how these smaller, quieter scientific findings actually build up the bigger picture over time. Bass are already common and well established throughout the Illinois river system, so unlike alligator gar, there was no reintroduction program needed to get them there. What researchers wanted to understand was simply whether an abundant native predator that was already present might be doing more work against young carp than anyone had previously measured. Their published findings showed a real size-selective predation relationship, meaning bass were shown to target carp specifically within a window where the young fish were small enough to be viable prey. It's not a dramatic single-species solution, but it adds another confirmed evidence-backed piece to a puzzle that increasingly looks like a combination of factors working together. Sustained human harvest doing the heavy lifting, existing native predators like bass contributing at the margins, and newly restored predators like alligator gar expected to add a longer-term generational contribution as their populations mature over the coming decade. Taken all together, this is a story about what actually works against a massive established invasive species problem, and it's a more useful story precisely because it's accurate. It's not a tidy accident. It's not a single hidden hero. It's the product of persistent funding, coordinated agencies, honest scientific monitoring, and the slow, patient work of correcting an old mistake by bringing back a native predator that never should have been wiped out in the first place. The Illinois River isn't fixed, and nobody working on this problem would claim that it is. But in the corridors where the effort has been the most sustained and the best funded, the numbers are finally moving in the right direction. And for once, that's exactly what everyone involved was actually trying to make happen. There's also a lesson here about how easy it is for a genuinely good story to get exaggerated into something more dramatic than reality, especially once it starts spreading online. A story about a massive, well-funded harvest campaign slowly working, reinforced by patient, decade-long conservation science, doesn't sound as flashy as a secret predator nobody planned for suddenly turning the tide, but the real version is arguably more impressive, not less. It shows that human institutions, working together across state lines and federal agencies, backed by researchers willing to publish findings that are cautious rather than sensational, can actually make measurable progress against one of the most stubborn ecological invasions in the country's history. Alligator gar didn't sneak up on anyone and quietly save a river system by accident. They were deliberately, carefully brought back by people who understood exactly what they were restoring and why it mattered, and who have been honest all along about the limits of what that restoration alone could achieve. That honesty matters, because overstating a win can end up doing real damage down the line. If people believed alligator gar alone could handle the carp problem, funding for harvest programs could quietly shrink just when it's needed the most. And the real progress being made in places like the Upper Illinois River could stall or reverse. The scientists and agencies involved in this fight have been careful not to let that happen, which is part of why the numbers keep improving instead of leveling off. Progress like this doesn't happen by accident, and it doesn't keep happening on its own either. It keeps happening because people keep funding it, monitoring it, and telling the story of what's actually working, instead of the more exciting version that isn't quite true.